Hello everyone, welcome in the today's lecture. Today we are going for a problem in which we are given an array of n integers and an integer sum. We have to find out a pair if it exists such that the sum of the two numbers of a pair is equal to the given sum. Okay, so let's first understand the question with an example. Let us consider an array of integers uh, having 2, 5, 3, 15, 34, 27, 1 and 9 as the elements, and we have to check for the sum equal to 20 if it exists between any two numbers in this array. So we all know that the answer here would be 5, 5 and 15. If we add these two elements, then we would get 20. But how can we get this pair is the problem. So first of all, I want you all to guess for the answer, and please pause the video and start thinking. So let us take the first method, and that is the brute force method. In brute force, we are going to check each and every possible pair and add it up to check for if it equals the given sum. But but it would be too complicated, require a lot of time, and anyways it takes order of n square time complexity. So we would not definitely go for this. Can you think of any other solution to this problem? How is it? Let's go for sorting. If we sort all the numbers from smaller to the greatest, what we can do is we can use two pointer method. That is, point the first pointer at the beginning of the array and the second pointer at the end of the array, and check for the given sum. If the sum of these two pointer elements equals to the given sum, then we have excellent, we have got the answer. If it is less than the given sum, then we can increment the first pointer, and if it is less than the given sum, then we can decrement the last pointer. And in this way, what we are doing is we are slowly we are arriving at the given sum. If it exists, then we would get that, and if we don't get that, and we are in the end, means tend to return false. So here is the algorithm. See, we have to check the temporary sum of array of I plus array of j. If this is greater than given sum, then decrement j and continue. If it is less than the given sum, then increment I and continue. If equal, then return true. We have find out the answer. What about complexity of this algorithm? Is it order of n or something else? It is order of n log n for sorting. See, we are getting order of n for the two pointer algorithm, but for sorting we would require order of n into log n. So overall, the worst case complexity is order of n into log n. Any other way you can think about? Anyways, we can have another solution. Can you think about the solution? Any other way of doing this in order of n time complexity? Here is it. Here is the code for the sorting algorithm. See, we are using the while loop for and placing the two pointers I and j, one at the beginning and one at the end, and checking if there exists a pair with a given sum. And if we don't find it, if we find it, then we return true, and if we don't get it, then we return false in the end. So one more method I am gonna tell you, one more way of doing this is using hashing. In hashing, what we can do is in an array, we can mark each element in an array to be present. Okay, and in and while we go through the array next time, we can check if the conjugate of an element, that is the difference between the given sum and the element, if it is present already or not. See, if the pair is 5 and 15, and we have marked both of them, 5 is also present, 15 is also present. Now, if we go through 5, we can check for 15. 20 minus 5, if it is present, then we have got the answer. So this is the same technique we use here. First, mark all the elements of the array in the hash map, then traverse the array elements in linear fashion and check if their conjugate, that is the difference between the sum and the element, is already present or not. If it exists, then return true. So this is hashing, and this requires order of n in time complexity, but order of n space also. For storing the elements, for marking the elements in the hash map, we would require order of n in space complexity. So here we are going to see the algorithm of the hashing technique. For all elements from I is equals to 0 to n minus 1, mark all as present in the hash map. Now trace the array from I 0 to n minus 1. Check if sum minus array of I is already present or not. If it is, then return true, else continue. In the end, if we don't find it, then we return false. Okay, so thank you. Here was our hashing technique. I would appreciate if you find any other method and please mail me the same. And I want you to constantly think on the problem, continuously think on the problem. I will see you next time. Goodbye.